Platform Analytics provides for advanced analysis of HPC data, including jobs, resources, licenses, and more. In this module, I'll focus on workload accounting. In this view, I'm looking at the total number of jobs run over a period in each geography. The larger the circle, the more total jobs were run. The jobs are broken out by the number of processors that they required. In the UK and Australia, most jobs run on a single processor shown in blue, whereas in North America, many jobs are parallel, running on 4 or more CPUs. As with other views, I can look at different measures like total runtime. I see the table and breakdown by CPU count change to reflect runtime rather than job counts. I'd like to understand what types of jobs in each geography are taking the longest to get scheduled. I can change the measure to job pending time. Interestingly, single processor jobs in the UK are pending much longer than jobs anywhere else. In the UK, the combined pending time was 37 million minutes for all jobs in March and April. I might want to filter by the amount of memory the jobs are using to see if memory requirements might help explain the delays. I'll focus on jobs that require between 8 gigabytes and 16 gigabytes of memory. This view shows us that only 2 jobs fell into this category. In total, they pended for 1,440 minutes before being scheduled. The color coding tells us that these were 496-way jobs. Long-running parallel jobs tying up all the resources could explain why single processor jobs are all pending for such a long period. I'll restore the view so I'm looking at all jobs. I'll select the Projects tab because I'm interested in understanding workload by project. In this view, instead of looking at jobs by cluster in each geography, I'm looking at jobs broken down by project. I can drill down on a project of interest and see information about the associated jobs. I see that over 1,700 of my almost 30,000 total jobs were related to Project 6. The orange portion of the graph is showing me jobs that exited with an error of some kind related to the project. I'll filter on exited jobs to see this more clearly. And I'll place my mouse over the exited jobs bar. Exited jobs with significant runtime represent wasted resource, so I'm interested to see how much CPU runtime was wasted by the team working on Project 6. I'll change the measure to runtime. I can calculate that these 949 jobs represent 161,000 minutes, or over 110 days of runtime in total. This would have resulted in reduced service levels for other project teams. It's important to get to the bottom of issues like these, and Platform Analytics gives us the tools to solve problems easily. I'll deselect this project. And I'll reintroduce completed jobs back into the analysis. I'd like to look at projects on just the UK cluster, because you recall from earlier analysis that they had the most jobs and the longest pending times. It becomes apparent quickly that some projects are using significantly more resource than others. Recall that pending time was an issue on this cluster, so I'll change the measure to pending time to see what UK projects are suffering delays. And I'll look at the average pending time instead of totals. No surprise, but many of these project teams are waiting days to get jobs scheduled. 157 jobs run by this project team waited on average 2 days to run, only to exit before they were completed. Being able to perform this kind of analysis is critical. We could easily reach incorrect conclusions and make bad planning decisions if we didn't understand what was happening with these jobs and who they belong to. Let's continue our tour and select the Queues tab. Scheduling policies are often implemented in queue configurations, so it's important to see metrics by queue. This helps us tune policies and make the environment more effective. This view by queue is showing us that fully half the jobs submitted in our main queue are failing to run to completion, and jobs in that queue are pending the longest. Almost all of our low priority jobs are getting preempted before they can complete, possibly indicating a problem. We may as well not even be running these jobs since they're just wasting resources and costing time and money. Instead of looking at how long jobs waited in each queue, I'd like to look at the actual number of jobs involved. And again, we get an important insight. Jobs in the low priority queue have all been preempted or killed, but there were a negligible number of them. Only 3 in fact. We might wonder why we have this queue configured at all since it's so rarely used. Let's look at all clusters. Now I see all queues across all clusters globally rather than just the UK cluster. I might want to drill into the months of March and April and look at jobs submitted by day to each queue. I can look at average pending times for each day to assess how consistent service levels are to users through the month. Now I see average job pending time by day for each queue. I could filter this data for any individual user or project to get a fuller understanding of their specific service levels. For convenience, the Workload Accounting Dashboard in Platform Analytics has a quick reporting tab. Let's look at this now. Recall from before that we had long pending times only on the UK cluster. I'll change the measure to CPU time for all jobs running on each cluster and see if there are differences between geographies. Notice that the average CPU time for each job is longer in Canada and the US than in the UK, showing very different workload patterns. In North America, users are submitting fewer, longer-running jobs. I'll examine this by project. Now it's clear to me what the average CPU time is by job associated with each project. I might use totals instead of averages for chargeback accounting purposes to determine CPU time by project overall. The quick reporting dashboard can be used to easily answer all kinds of business level questions. Let's say we wanted to get a sense of the average job turnaround time for each project. I can easily get this statistic by user. Now I'd like to understand total CPU time consumed by each user during a time period of interest. What would be really interesting to understand is what users are consuming large amounts of CPU time running jobs that fail before completion. By addressing the underlying cause, I can improve service times and increase the apparent capacity of the clusters, and possibly avoid or defer new equipment purchases. Now I see just CPU time by user for exited jobs. User 5 appears to have wasted almost 10 million CPU seconds in just the last couple of months. That's 115 processor days, or the equivalent of tying up a 4 CPU machine for an entire month. Finding and identifying the reasons for this waste can pay dividends in terms of productivity and help contain cost. As a final example, let's look at job pending times by user so we can see who's getting frustrated with poor service levels. Now we see what users have long total pending times for their jobs. We can examine averages, minimums, and maximums as well by changing the roll-up type. Total pending times related to the number of jobs submitted, so I might want to restrict the view only to jobs that pended for more than 60 minutes to see who's most impacted. Now I see pending times only for jobs that waited more than 1 hour to be scheduled. I see the number of jobs as well, which gives me a better understanding of what this really means from a practical standpoint. 14,400 hours is 10 days, so user 5's 3 jobs on average took 3 days each to be scheduled. Armed with this kind of information, we can consult other analytics dashboards to understand why jobs are pending so long. There may be insufficient job slots available in a host group, for example. We can often make simple scheduling policy changes to reduce wait times dramatically and boost productivity for these users. I'll look at the Rankings tab. Rankings provide another useful way to visualize and understand the nature of our workloads. In this view, I'm looking at jobs that have run in March and April on the US cluster. I see jobs broken down by how much memory they've used, how long they ran, and how long they took to be scheduled. The information is provided in both tabular and graphical form. I can see quickly that the majority of jobs ran for more than 4 hours but less than 1 day. I also see that a little more than 10%, represented by the blue slice on the second pie chart, ran for more than a day. I'll change this view and add all my clusters in again. Now I can analyze workload rankings globally. Some things jump out at me, like a dramatic increase in the number of long-running jobs in April. The number of jobs running for more than 1 hour went from 1,600 in March to over 20,000 in April. This could explain why the pending times jumped so high. In March, only 4 jobs waited more than 1 hour to be scheduled, and in April, 1,500 jobs were forced to wait more than 1 hour. Platform analytics gives us insight into our operations that would be nearly impossible to get without this kind of capability. 5 minutes spent understanding the data can avoid days of data gathering and research and result in better quality decisions that are based on facts. I'll finish up this section on workloads by looking at the User tab. This view allows me to get granular and look at a variety of user-related measures by cluster, project, and queue. It also allows me to restrict my analysis to particular buckets, jobs that use various amounts of memory, long-running jobs, short-running jobs, and so on. I'll look at total CPU time consumed by all users across all global clusters. I have a clear view of what user is running what amount of CPU resource and how many of the jobs complete and exit. I can also see how user activity varies day by day. If I click on a particular date in the chart area, I can see graphically what users were active that day and what level of resource they consumed. Active users are highlighted in the graph as shown here. I'll go up a level and look at monthly summaries. I might want to sort my users to see who's using the most CPU time over a period. Now I see all my users sorted by total CPU usage over the period of interest. I can export this data if I choose. I might want to focus on the subset of my users submitting long-running jobs between 1 and 4 hours in duration. And now we see our smaller community of users. We could perform more analysis looking at them by project, by cluster, understanding the number of jobs they're running, and so on. Let's wrap up and summarize some of the benefits of the workload accounting dashboards. With Platform Analytics, we can perform workload accounting and analyze activity by project and by user. With better insights into workloads, we can understand and improve service levels. As we refine scheduling policies, we can monitor the results using Platform Analytics, enabling us to measure the positive impact of changes. By providing for data-driven decisions, Platform Analytics helps alleviate resource bottlenecks and boost overall productivity. I hope you've enjoyed this overview of Platform Analytics workload accounting capabilities.